The scientific revolution. I know y'all are zoning out, but it's 1600 and 1900. Much of the Asian knowledge on some of these astronomical concepts, as shown on the last segment, had spread through trade and colonialism to Europe. The next developments in European astrophysics happened during the scientific revolution, when our first two guests, Nicholas Copernicus and Galileo Galilei, created and affirmed the European heliocentric theory after seeing it for themselves through telescopes but calculating the results. Churches tried to press them but failed thanks to the printing press and other factors. Then we got Johannes Kepler, who created the laws of planetary motion, stating that planets move in elliptical orbits, not circular ones, that planets move around the sun or a star at a steady speed, covering equal areas and equal amounts of time, and that planets' orbits all have a constant factor by the laws of physics. Then we've got Isaac Newton, who finished the law of universal gravitation, or this equation, showing the amount of gravitational force each object exerts on another. He also found the law of inertia, stating that planets and stars remain in motion in their velocity unless acted upon by outside forces like gravity, causing them to circle around, in this case, the object exerting it and change their direction, creating the orbits of many of the celestial bodies. He also put together the piece of calculus. So shout out to people taking calculus courses, but it's actually a huge development, as much of astrophysics is actually made up of calculus, and it has to do with the relative motions or positions of objects, creating many of our modern physics constants. Joseph Louis Lagrange and Pierre Simon Laplace added to Newton's work with finding out how planetary orbits remain balanced with many disruptions. Laplace also created this nebular hypothesis, an early evolutionary theory to explain why nearly all of the bodies of the galaxy, or at least all of them in the solar system, revolved counterclockwise, showing the prehistory of our galaxy. Also, we had Johann Eller Bode, who created the Titus-Bode law, identifying a numerical pattern between the distances of the planets to the sun and the moons to a planet of a planet to the planet. This era ended with new thinking about the measurement and edge of the galaxy and categorizing celestial bodies in ways like this. These developments and the slow spread of calculus marks the end of this segment, as Europe caught up with the Asians on these deeper lost concepts.